Find the coordinates of the centroid of the area bounded by y equals x to the power of 2 over 3, x equals 8, and y equals 0. So we have to find x bar and y bar in order to find the coordinates of the centroid. So let's look at x bar first. Well, in order to find x bar, we need to look at vertical elements here of width dx, and we need to be able to graph this function y equals x to the power of 2 over 3. Now this function may be a little hard to graph, so you could use a table of values or some graphing utility if you wanted to see what that looked like. And then you have x equals 8 is pretty easy to graph, right? It's just a vertical line at x equals 8. So here's our y2 is equals x to the power of 2 over 3 here, and then our y1, notice, is 0 because we're going from a top function to a bottom function when we integrate this, right? So we're subtracting here. So according to the centroid integral here for x bar, let's look at what our functions y2 and y1 are so that we can substitute them in here. And our limits of integration too. So here is the template for the x bar. Here is our actual things that we're substituting in. So 0 to 8 is our limits of integration because we're going from left to right, 0 to 8. And then x, and then our y2 is the top function, just x to the power of 2/3. Take away our bottom function is 0. Okay, and on the bottom, integral again, 0 to 8. And our y2 is x to the 2/3, take away y1 is 0. And as before, we can't cancel anything here on the top and the bottom. We actually need to find the integral of the numerator and denominator before we could actually cancel anything. So looking at the result here, x times x to the 2 over 3, that's you'd add those together. This is x to the 1, and 1 plus 2 over 3. If you want to check that out, you can check that out. That's actually 5 over 3. And on the bottom we have x to the 2 over 3. So now we integrate, and now our integral signs disappear when we integrate. So I've integrated here, and I get x to the 5 over 3 plus 1 over 5 over 3 plus 1. Just remind you of the integration rule, right? It's our power rule we add here. And just rewriting that as, well, first of all, 5 over 3 plus 1 is actually 8 over 3. You can check that out as well. That's just some simple fraction addition there. And then divided by 8 over 3, but I just flipped that to become 3 over 8, as you probably saw in the first video. And I did the same thing with the bottom, 2 over 3 plus 1. You can check that out. That's 5 over 3, and then divided by 5 over 3, well, you flip that to become 3 over 5. And so now we evaluate this at these limits of integration here. So first I plug in 8. So I'm looking at 8 to the power of 8 over 3. Remember from the last video, that's the third root of 8 raised to the 8. So the third root of 8 is 2. Raised to the 8 is actually 256. Times 3, and then divided by 8. So from all that you get 96, right? You can check out the math there. And this of course is 0, and this bottom guy is 0, so then we need to go to the top one here. Or sorry, the bottom one here. So we do 8 to the power of 5 over 3, that's the third root of 8 raised to the power of 5. So third root of 8, that's 2. Raised to the power of 5, that's 2 to the 5, that's 35. Times 3 is 96, so 96 over 5. And of course we get 96 divided by 96 over 5, and we do our fraction division rules here, we will indeed get 5. For the x bar, that's the x coordinate of the centroid. So finding y bar, same thing. So notice I've redrawn the graph here. This time though we have to come at it from a different perspective because now we're taking horizontal elements going from some bottom limit to some upper limit here. And plus, we need to rearrange this equation, this function here. So our function was y equals x to the 2/3, and we need to solve for x. And if we do that, that would just be like raising both sides of this equation, I guess, to 3/2. And then so x1 then is equal to y to the 3/2, or 3/2. And x2 is the right function, which is 8. So when we use our y bar here, this time, notice the difference in the centroid integral here for y bar. This time we're going from c to d, which is a lower limit, to an upper limit, right? Not left to right this time, lower to upper. So we're actually going from 0 to 4 this way, because we have to sum up all these horizontal elements dy from bottom to top. Now notice here, I haven't drawn this one in this time, but we actually would have to go, we're going a distance from the y-axis to the dx element for the x bar, and for the y bar we're going from the x-axis up to the element dy. I just haven't drawn it in this time. But here we get our formula. It's y times x2 minus x1 dy, so our x2 is 8, our x1 is y to the 3/2, integrating from 0 to 4, and on the bottom I think you can see exactly x2, x1 again, 8 and y to the 3/2, and now we simplify this a little bit before we actually integrate. So y times 8 is 8y, y times y to the 3/2, so that's y to the 1, and times y to the 3/2. So we add these exponents, and if you check that out, 1 plus 3/2 is actually 5/2. Just some addition of fraction rules there that you can check out. And on the bottom, this doesn't change, right? Still 8 minus y to the 3/2 dy. So then we integrate. Once we integrate, the integral sign disappears. So we have to use our integration rules here. And when we do that, we integrate 8y, we get 8y squared over 2. When we integrate y to the 5/2, we need to add 1, so 5/2 plus 1. Again, this is something you can check out. Fraction addition, it's 7/2. And then it's divided by 7/2, which I just flipped it to be 2/7, right? It's easier to work with that way. Integrate it at 0 and 4. We need to substitute those in the next step. So the denominator here, the integral of 8 is just 8y. The integral of y to the 3/2, that's add 1 to the power 3/2, and you get 5/2, and then divided by 5/2. But like I said, easier to work with if we flip that, so that becomes 2/5. Okay, so integrated from 0 to 4 as the numerator, same thing. So when we do this, when we integrate this, when we substitute here now, we'll substitute in 4s first. So 4 times, well, first of all, 8 divided by 2, I've simplified that to be 4. So that's 4 times 4 squared minus 2/7, 4 to the 7/2. And then we subtract the zeros, but the zeros contribute nothing here. They're always 0 as before, and the same thing with this part on the bottom. So the bottom part becomes 8 times 4 minus 2/5, substitute in the 4, raised to the 5/2. So then we need to figure out these top and bottom here. So 4 times 4 squared, well that's 4 times 16, so that's 64. Now 4 to the 7/2, now that is the square root of 4 raised to the 7, which is 2 to the 7, which is 128 times 2. That's 256, and then divide that by your 7. And then you have a little bit of fraction subtraction to do here. Multiply 64 by 7, put it all over 7, and then once you do the subtraction here, you'll get 192/7 on the top. And then the bottom, you get 8 times 4, 32, take away the second, or square root of 4, again, which is 2, raised to the 5, so that's 32, times 2 is 64, divided by 5 here. Again, a little bit of fraction subtraction. If you do that, you'll get 96/5. Then when you divide these two, we're doing division of fractions here, so we multiply by the reciprocal of the 96 over 5, and I'll let you do that math, and you should come out to 10 over 7 when you do that. So the coordinates then for the centroid of this thing is actually at x coordinate of 5 and a y coordinate of 10 over 7.